All right, welcome back, everybody. I'm moving on to new parts. This is now already part 5 about syntax. You will have the exercises on HDFS normally, I think, starting this week probably, right? We had cloud storage last week and HDFS this week. All right, so syntax. You remember the data shapes that I told you about. These are the 5 fundamental data shapes: tables, trees, graphs, cubes, and vectors, which is the newest shape that we use with unstructured data. And you might also remember this technology stack that I told you about. It's this huge stack that we are rebuilding bottom up, but on a cluster of machines instead of a single computer. And today I'm going to focus on the syntax, a little bit of encoding, but mostly the syntax. So syntax can be one of many. I'm pretty sure everybody heard of CSV. Who did hear of CSV? Right? What does it mean? Comma-separated values, exactly. CSV is the syntax for tables. As it turns out, there's many others. We have XML, JSON, that we are going to look at in depth. We have these are trees. RDF XML, that's for graphs. Turtle is also for graphs. XBRL is for cubes. And text, I was about to say it's for vectors, but it's just that when you have these vector databases, it's LLMs, so they actually take a natural language as inputs. And so here's the general idea. On HDFS or on S3, we store zeros and ones, right? An object or a file is just made of zeros and ones. But we want to store data in there. And we saw that the data can be tables, can be trees, can be cubes. And so the real question in today's lecture is, how do we store tables or trees or graphs or cubes as zeros and ones? And the answer, or partial answer for today, is we just use an intermediate representation as text. The idea is that text can be stored as zeros and ones. That's called an encoding. We have ASCII, UTF-8, and so on. So all these ways to represent text as zeros and ones. And that's the bottom layer. So you can read and write zeros and ones from HDFS or S3 and then get it as text. And once you have the text, you can get out of that text an in-memory representation of the data. And what I mean with an in-memory representation is that in the memory, you are actually having a table structure or a tree structure or a graph structure or a cube structure in memory with the pointers and the way you organize the layout in the memory of your machine. And that needs to be parsed from a text file. We call it parsing, right? Parsing means you have a text file like CSV and you parse it and you get a table in your memory. That's exactly what happens when you open a CSV file with Excel and it appears as a table on your screen. You've parsed the CSV file into a table in your memory and then shown on your screen. The same goes for XML and JSON. When you have an XML or a JSON file that is actually text, but it's text that happens to be XML or JSON, you can also parse it, but then you don't get a table. You get trees. And the same goes with other syntax with cubes and graphs and so on, but we are not focusing on cubes and graphs. So parsing is the name that we give when you take text in some syntax like XML, JSON, CSV, and you build a memory representation out of it. The opposite movement is called serializing. You have your data in the memory and you serialize it as XML or JSON or CSV. So when you create a table in Excel and you save it as CSV, in fact, you are serializing the table as a CSV file, right? Does that make sense? right? So parsing, serializing to construct the memory representation from a text file, and writing and reading, that's to write or read the text file from a GFS or S3 and so on. So this is the high-level overview of how it works. Now, I'm not going to focus too much on CSV, just maybe a few slides, but not too much because this is the good old tables, right? And CSVs are rather simple to understand. It's just a bunch of rows and columns. So I'm going to focus more on XML and JSON. The reason I'm going to do that has to do with throwing away the normal forms that I mentioned a few weeks ago. So the very rare slides I'm going to have on CSV are right here. So this is an example of CSV file. You can see it's text, right? CSV is text. And comma-separated values, because you have the commas that separate, so ID, last name, first name, these are the three columns. This is called the header line, which has the headers. And then the other two rows are the records. And you have 1, Einstein, Albert, and you see the commas are used to separate the columns. Now you can tweak it. People might want to use semicolons or spaces or tabs or whatever instead of commas. Absolutely, this is flexible, right? Who sees, when you look at the above CSV text file, who sees that this is a table, as shown below? Who sees that? Right, most of you. If I would show you now a CSV file that I downloaded from the internet and I show it to you, who would see the table? Most of you, right? With the new lines and the commas, you can see the table. All right. Now, it's not as easy as it seems because this is a simple case. The problem comes when you start having weird things like what if you have commas in the data? For example, you might have general spatial relativity, and that comma here between general and spatial is not a comma that separates the column, it's a comma that belongs to the title. How do you do that? Well, you add quotes, right? You can surround with quotes, general spatial relativity, and that says, no, that is a bunch of text that shouldn't be cut. So the comma is not a separating comma. But the problem is now, what happens if you need quotes in your string, right? And then you see you open a can of worms here. Because now, if we want incompleteness theorem and put incompleteness in quotes, I need a way to tell that these are quotes that are not meant to tell that the comma is not separating. It's actual quotes that needs to be part of the data. And so the way you do that, or one of the ways to do that, is to double the quotes. So now you have incompleteness theorem in quotes, and the quotes around incompleteness are doubled. This is called an escaping sequence. Doubling the quotes means that you mean a real quote as part of the data. As you can see at the bottom, you see the quotes in the data. What I'm saying here is it can really get complicated. And anybody who has done machine learning and that tries to download a CSV file and then open it with some machine learning software and try to study the correlations and get some visuals, you probably have gone through the agony of selecting the configuration of the CSV. What is my separating characters? How are the quotes separated? Is it UTF-8? Is it ASCII? And so on. And that requires some work. So we do have a standard, RFC 4180, it's called, that specifies CSV. In practice, it's a bit of a mess. People do a little bit what they want, and so it requires some work to read or to write CSV files. Luckily, that's not the case with XML. XML is just exactly the way it is, and you don't have any margin of interpretation. That makes it much easier to use. And to some extent, the same with JSON, except that JSON does have a bit of flexibility. Okay, so you see, this is a textual representation of a table. Now, you saw that tables have normal forms. If you have a relational table that is behind your web shop where you sell your products over the internet, we saw in information systems for engineers that you should have several tables. A table for the product, a table for the customers, a table for the orders, and so on, right? The reason for that is you want for your website to run smoothly, even as people place orders, right? So this is the reason why you want all of these tables. So when you have a web shop, you are in the write-intensive phase because your customers are constantly placing orders and registering and so on. So you constantly write to the database. This is where you need PostgreSQL or that kind of database, highly normalized. But in this lecture, in most of the weeks, we are not going to want to have a database that we write. We just want to analyze data, to read. So what's actually going to happen typically is we download a bunch of data from the internet, we put it on HDFS, and we analyze it, right? We don't modify it. We just put it in there as it is, and we read it as it is. And the really nice thing about read-intensive workloads, where we don't care about writing the data, is we just don't care about normal forms anymore. We just throw them away. We don't care. Yes?
Yes, Manuel have a question about the CSV in the first. Yes, why do we need the external double quotes in ID2? There are no comma. There could we not just put the double quotes here?
That might be. I'm wondering if double quotes can be used outside of quotes. That's just the thing. If you would put directly a double quote without the external quotes, it might interpret that as an empty string. I'm actually not sure. I would have to look offline. It might also depend on the, as I said, it's a bit flexible, so maybe different engines might do it differently. So it might be that the surrounding quotes around incompleteness theorem are not necessary. It might be. We will check offline. Right. My recollection was that the double quotes had to be inside quotes, but again, I might be wrong about it. Right? Okay. Very good. But you see, it's complicated. This is basically what I'm saying here. It can really get complicated. But you see the benefit of data independence, because the beautiful thing about using a spreadsheet software is you don't need to care about CSV. You don't care how it's stored. All you care is about your table. All right. Okay, so now we are on the right, read intensive. We couldn't care less about normal forms. So what we do with everything we've learned in information systems for engineers, we just threw it away, right? So this is why I told you don't worry too much about normal forms, right? So second normal form, third normal form, Boyce Code normal form, all in the trash can. So what we get out of this is that instead of this, where we have several tables beautifully organized, so one table of products, one table of sales, one table of customers, instead of that, we throw that away and just group it in one single enormous table that we play with. Now, you remember that a table is a collection of rows. The rows are also called records or tuppers, or there's plenty of names, right? So the one highlighted in green here, phone 800 John 1, that's one record, one tuple in that table. And you can see it as a map from attributes to values, from strings to values. Product is assigned to phone, price is assigned to 800, customer is assigned to John, and quantity is assigned to 1, right? For the record highlighted in green. So this is basically the mathematical view of this record. But now we will see that we are going, instead of the mathematical view as a partial function like this, we are going to prefer to view it as text like that. Right? Do you see? It's the same thing. Product, price, customer, quantity, these are my attributes in my table. Now I'm calling them keys, right? And then I have a column, and then on the right, I have the actual values, phone, 800, John 1. Do you recognize this syntax? Anybody? What it's called? JSON, exactly. This is JSON. That's the focus of today. So JSON gives me a textual representation of that row. CSV is also that. In CSV, I would have phone, comma, 800, comma, John, comma, 1, right? And the attributes, product, comma, price, product, customer, comma, quantity, would be on the first header row, right? And now I have this alternate textual representation called JSON. Very good. So that means that if I have now all of my records, one by one, every one can be represented as JSON. And many data sets that we download from the internet are exactly that. On every line of this huge JSON lines file, it's called the JSON lines file, every line has a JSON representation of one record per line. Exactly like in CSV, where there is one record per line. But the one difference with CSV you notice is that product, price, customer, quantity is repeated on every line, right? Do you see that difference? In CSV, it's not. shared across the entire file. So now that we've seen that, this is the JSON syntax for this table. We are now in the middle of dropping these constraints. So I told you relational integrity, domain integrity, atomic integrity. We are throwing all of that away and entering the NoSQL world with the JSON and XML syntax. So we are just, it's fun today. We're throwing things away. We're throwing normal forms away. We're throwing Boy's code. We're throwing the first normal form. Does anybody remember what the first normal form is? Also called atomic integrity. Does anybody remember first normal form? On Zoom, the first normal form? Hint, the Inception movie. Exactly. Yeah, every cell is atomic. Just like you have a dream in a dream in a dream in a dream in Inception, the first normal form says you cannot have a table in a table in a table in a table. But now we're throwing that away. So in this course, we are allowed to have a table in a table in a table in a table, right? And we're going to have that all over the place. So in this course, big data for engineers, this is allowed. We can absolutely have a table in a table in a table in a table because we're throwing away the first normal form. That would not be in the first normal form because of that. And the beautiful news I have for you is that CSV cannot do that. In CSV, you cannot store tables in tables in tables in tables. CSV has to have the first normal form. But in JSON, we don't care. In JSON, I have absolutely no problem writing the JSON for that. Do you see how it's done? I have in orders these square brackets. It's called an array, we will see. And then a list of what's called an object with the curly braces. So you see customer quantity, customer quantity, customer quantity. This is a table in a table. And JSON can do that. Who sees that? Right? So this is JSON. I'm going to drive you through it, but this is the idea here, that JSON and XML allow me to have tables in tables in tables. And what's more, let's break another rule. So here I broke the first normal form. Let's break the relational integrity. Remember, the relational integrity says all of the records have the same attributes. Let's break that rule. Here, it's broken, right? So now I have broken, you see Mary doesn't have any quantity. So I broke relational integrity. But do you see that I also broke the domain integrity rule because now in quantity I have whatever, right? So 1 in text, 2, there's not even any type anymore here, right? So I also broke the domain integrity. And you see JSON has absolutely no problem with that. Because in customer Mary, I just don't put any quantity and that's fine. Quantity 2, that's an integer. Quantity 1, that's a string. So I have absolutely no problem with JSON. That is so cool because look at what we've done here. You remember these 3 things, domain integrity, atomic integrity, relational integrity. On that slide, we are breaking all 3 of them. And so the message today is JSON and XML are perfectly capable of breaking these rules. CSV, not so much, but JSON and XML can. Right. Who sees that the JSON syntax here corresponds to the record shown above? Right, most of you, okay. I drive you through JSON, I'll take the time to show you JSON, but the goal is that when you look at this JSON, you kind of automatically in your brain see the view, right? And basically, this is what I call serializing and parsing. Parsing would be you take the below one and you parse it into what you see above, and serializing means you take what you see above and then serialize it to the JSON, to the text that you see below. Parsing, serializing. But we'll see that actually the table representation might not be the best one. We'll see that it's better to use trees than tables rather than these weird views with broken stuff, right? We have a broken cell here and so on. In other words, since we're breaking rules, we are moving from the flat, homogeneous, beautiful world of PostgreSQL and SQL and CSV and tables, and we are moving over to an even more beautiful world of nested heterogeneous data. So now I have tables that might have extra values, that might have missing values, that might have invalid values, and that might have nested values. So I'm breaking all 3 rules. Nested values break atomic integrity, first normal form. Invalid values break domain integrity, and missing values and extra values break relational integrity, right? So now what we have on the right is what we are doing today. And so that means yet another example. On the left, you have a homogeneous collection of flat items. On the right, you have a heterogeneous collection of arborescent items. Arborescent is just a fancy name for table in a table in a table for a tree, right? And so you see that the table that you have on the right, which actually is not a table because it's breaking all these rules, we will represent it as JSON as shown completely on the right. Who sees that the JSON you see on the right corresponds to the visual in the middle? More or less? Okay. So you can take the time offline to look at it precisely. All right. And so where we are when we do that is somewhere in the middle between structured data and unstructured data. Structured data, that would be tables, right? That respect all three rules. That's structured data. Unstructured data, that would be text. Just a novel would be text, right? The ones you feed in an LLM. What we have today is semi-structured data. It's not quite just text, because what you see here on the right is not an English novel by Dan Brown. It's just JSON syntax. So it does have some structure, but it doesn't have the full structure of a table because it breaks some rules. So this is why we call it semi-structured data. It was a big buzzword 20 years ago. We are going to see that what we cover today, XML and JSON, are standards. XML is a W3C standard. W3C is the same standardization body that standardizes the web, HTML, HTTP. It's all standardized by the W3C. It was founded by Sir Tim Berners-Lee, who invented the web. And JSON is an ECMA international standard. It's also an RFC standard, but more recently an ECMA international standard. ECMA International standardized JavaScript. Who heard of JavaScript? Right, so it's standardized as an ECMA standard, also known as ECMAScript, right? So this is another standardization body. This is extremely powerful because the fact that these are standards means that people align on them, and you can have thousands of libraries in Python, in Java, in R, in any language you can ever imagine. I'm pretty sure you will find a library that can read XML or JSON. And that is because they are standards. So it's extremely important that they are standardized. So now, let me look more into details into this syntax. So again, remember, the syntax gives us a representation as text of some data. So computer scientists call it a language. So of course, you might imagine a language, you might know English, French, German, Hindi, Chinese, and so on, right? These are human languages. You might know programming languages like Java, R, Python, and so on. But in fact, the term language for a computer scientist in theoretical computer science is a very general word that can describe any text that you consider well-formed, right? So JSON is also a language. XML is also a language, right? It just specifies if some text is well-formed or not under that language. You could do the same with well-formed. It's not called that way, but you could look at some text and ask, is it well-formed English? What that would mean is, are these actual English words? Is it the English vocabulary? Is it respecting the English grammar? And then you can say, okay, it's well-formed English, right? Maybe it's not well-formed English, maybe it's well-formed French. It has French words and the French grammar and so on. The same with Python. You can look at a text document and ask, is it well-formed Python? That would mean that it has the correct indentation, the correct functions, and so on. And if it correctly parses, it's again this word parsing, it parses as Python. It means that a Python interpreter is able to read it and understand it and execute it. And so in the same way, you can have a text document that is well-formed English or well-formed Python. You have text that is well-formed XML or well-formed JSON. And so in theoretical computer science, we describe a language as some stuff that is able to answer yes or no given any document. If I give you a text document, and I feed it into my system, then I can accept or reject it. And my language tells me if I accept it or if I reject it. So it means that if I give you any document and I can ask you, is it well-formed JSON? The answer is yes or no. Or I can ask you, is it well-formed XML? The answer is yes or no. It's really a yes-no question, right? And if the answer is yes, then I can parse it and have a memory representation. If the answer is no, then forget about it. If the answer is no, I cannot do anything about it. Right? Who is with me? Right? Remember that word, well-formed. I did not use the word valid. Many people make that mistake. They say it's valid XML, it's valid JSON. No, that means something else, valid. We'll cover it in probably 2 weeks. So I insist on getting used to using the word well-formed. Well-formed means it is or it is not XML or JSON. This is an example of well-formed XML documents. It's a text document that you can successfully parse as XML. Right? This is an example of well-formed JSON document. You can parse it and get it into memory, right? XML, JSON. You see, they feel semi-structured because there is a bit of structure, but it's not a table, right? So this is why we call it semi-structured. So now I'm going to go through JSON. You will see it's actually pretty simple, and show you the way it's built. So you know that if you learn a foreign language, or even your own mother tongue when you go to school and you're taught the grammar, you're taught the words, basically there's an organization in there, right? You have grammatical construct, you have subjects, objects, verbs, adverbs, and so on, adjectives, and so on. The same goes with JSON and XML. There is a bit of structure, and so it's like a Lego game. We have building blocks that give you the structure. So JSON and XML are made of building blocks. Well, the good news about JSON is there are only 6 building blocks, 6 of them, and that's it, only these 6. So you just need to learn the 6 building blocks and how you assemble them, and that's it, and then you know JSON. So I'm going to give you these 6 building blocks. Here's the first one. It's a string. A string is just a bunch of text that you put in quotes, right? So foo, F-O-O, is a string. By the way, just in case you don't know, I use foo and bar a lot. Computer scientists use foo and bar a lot. Do you know where it comes from? It's the German Furchtbar. That somehow they heard at some point Furchtbar, and then it became foo bar, and then everybody says foo and bar whenever they need an example. So foo, that's a string with 3 characters, F-O-O. And below, you also have a string, but what you see here that's a bit special is the backslash, because these are escape sequences, just like the double quotes in CSV. That means it's an actual quote. The backslash, together with n, backslash n, do you know what that is? It's a new line, exactly. So it means it's as if you would go to the next line, right? It's a new line. And backslash u means that it's a Unicode character. You know that Unicode is this huge catalog of symbols that are all indexed by an integer, right? It starts with the English alphabet, and then you have all special letters of English, French, German, and so on. And then you have all the scripts like Arabic, Devanagari, Cyrillic, Greek, and so on, right? So all the different scripts. And so there's this huge catalog with all letters. And nowadays, there's a lot of emojis in there, right? So you get all the emojis that you can possibly imagine. So it's a huge catalog, and every one of the symbols has some integer. And backslash u allows you to point to one of these symbols anywhere in the Unicode catalog, even an emoji, anything. And after u, you just put these 4 symbols, 005F here. It's just the code in the Unicode catalog of the symbol you look for. It's just that it's in base 16, right? Just like you write number in base 10, you write them in base 16, so it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? We have 16 symbols. So that's just the Unicode of some symbol that you want, right? And that can be any of them, any symbol in there. All right, but this is just an escape sequence, and when you do that, you actually have these symbols. So that string that you see below has, in fact, 8 characters. F-O-O, new line, bar, and the symbol that is identified with 5F. Right? Who is with me? That is a JSON string, right? Has to be double quoted. Second building block, numbers. Well, that should be familiar to you, right? So the numbers are basically made of digits in base 10, an optional decimal period. So you can have decimal numbers with digits after the decimal period, but it's optional, right? If you don't want any period, then you can. You can also have an integer that doesn't have any period. That's also fine. It can also have a plus minus, so a negative sign in front. And you are also permitted to use the scientific notation. You know, the scientific notation is when you write something times 10 to the power of something, right? So that's the letter E in there. It basically means it's minus 1.2345 times 10 to the power of plus 5, right? Who is familiar with that? It's just the scientific notation. And so that is, in fact, the number minus 123,450, if you do the math. All of them are well-formed JSON numbers. That is my second building block. Strings, numbers. Third one, Booleans, true, false, without quotes. It's that simple. I don't think I have anything else to say. True, false, these are the two Booleans. Null, that's my fourth building blocks. That is a special value that can be interpreted in many ways. You can say it's absent, or we don't know it, or you're not authorized to see it, and so on, but you can have a null in there. You can see it just in the same way in a PostgreSQL table, you can have nulls too, right, in there. So we have 4 so far, strings, numbers, Booleans, and null. These are the 4 atomic building blocks. Atomic because they are just, they don't have any structure, right? It's just atomic values. Plus the other 2 building blocks that have structure. The first one is an array. An array is just an ordered list of values. If you know Python, think of a Python list, right? This is just an ordered list of values. The values can be anything. In that case, my first value is a number, then I have a Boolean, then I have a string, then I have an object. That's my next slide, and then I have a null. Right? I could even have arrays. I can have an array and an array and an array, also without any problem. Right? So this is called an array. And my 6th building block is the object. An object is just a bunch of key value pairs. So on the left, you have the keys, foo, bar, str, obj, and q are my keys. And the values can, again, be anything. So with foo, I have associated a number. With bar, I have associated a Boolean. With str, I have associated a string. With obj, I have associated an object. With q, I have associated null. And I could also associate with an array, right? Note the difference that for the arrays, you have these square brackets, right? Square brackets. And for the objects, you have the curly brackets or curly braces, depending how you call them. Okay? And that syntax is extremely strict, right? If you have a square bracket, that's an array, and you separate the values with commas. And if you have curly braces, then you have an object, and you need these colons between the keys and the values, and the commas that separate the key values. And that's it. That's JSON. Who is with me? Right? Very good. And you see how it's recursive, because whenever you have an array or an object, you can put inside any values. Any one of the 6 goes in there, but only for arrays or object. If you look at the other, if you look at the other 4 here, you cannot put anything inside. These are the atomic ones, and only the structured ones, objects and arrays, can contain nested values. Okay? Very good. Now a few more words on things that are forbidden. It is forbidden to have a key in an object that is not a quoted string. What you see above here with the square bracket 1 or with the unquoted 2 is forbidden. That is not well-formed JSON. The second one is allowed. inside the string, you can have an integer or whatever because it's in strings, right? So it's in quotes. So you can have anything you want in there. So that's the first thing. A key in an object, what you see here on the left, must be a doubly quoted string. Now, you should be aware, and that's a little bit like CSV, that some libraries or some machine learning libraries will not complain if some keys are unquoted. It might also not complain if some keys are single quoted, right? There's some flexibility. But normally, you're not supposed to do that. So the general rule the rule of thumb that is used is if you create a JSON data set, then make sure to double quote all your keys if you create it. But if you download a data set from the internet, be prepared for the fact that they may not have quoted all the keys or that they may have single quoted the keys, right? So this is why some libraries accept it, right? So there is a bit of flexibility. But again, my advice, always double quote your keys if you create JSON. The second thing is that within the same object, you are not allowed at the same level to repeat the keys. That is also forbidden. So that object above, foo, is not well-formed JSON because you have multiple times the same key. And if you try to make sense of that rule, remember that these objects are supposed to be the representation here. Let me show this one of some records. So saying that I do not allow a repetition of the keys is the same thing as saying that in the table, I do not allow two columns to have the same name. For whom does that make sense? Right? It's pretty much the same idea. And this is why we don't allow this. Now, again, a word of wisdom. If you look at the standard of JSON, the RFC standard, the original one, it doesn't say it's forbidden. It just says you should not be doing that. It doesn't say you must not, it says you should not be doing that. So an object should have distinct keys. If you look at the ECMAS standard, they even removed that. They don't even constrain that you cannot have repeated keys. I don't know why, or what happened, or what was discussed. But what you should know is that at least in the database world, most of the database engines and database query engines will reject JSON that have duplicate keys. You might find some systems that accept duplicate keys, that exists, but in the database world, people don't do that. People do not have any duplicate keys, right? So this is why I'm telling you for the purpose of the course, even if it's a should, you should consider as something forbidden. For the purpose of this course, it is forbidden to have duplicate keys. Such a document with duplicate keys is not well-formed, right? To make it clear, I really mean duplicate keys in the same object at the same level. If the keys are in different objects, that's totally fine. For example, if I show you here this, I have several times the same key here, but it's okay because it's different objects, right? So here it's totally fine. And at different levels, it's also totally fine. Okay. Now, you will find plenty of JSON data sets out there. This is an example with what was called the Great Language Game where...
Yes, a question on Zoom before you go too far away. So Manuel asked, when do we use an array and when an object? What are the difference between them?
So the idea is that an array is an ordered list and an object is a record. So typically, you would use an array of objects. Let me put it that way. An array of objects gives you a nested table, right? An object allows you to associate keys with values. So it's really a mapping. It's called a map as an abstract type by computer scientists. It's called a map. And an array is called an ordered list. So you use an array when the order is important and it's just a list of values that you don't associate with anything. And you use an object where the order is not important because there is no order here between the keys. It doesn't matter. And where you want to associate values with a key. And so have in mind an object like this, put it in perspective with a database table records, right? It's part of a collection and you have your records and the keys correspond to the columns and the values to the cells. That's the way I think about it. And then the arrays, that allows you to have, for example, either nested lists inside a record, or that allows you to have nested tables when you have, for example, here there's an example where you have an array with 3 objects inside, and here you should see that as a nested table. Does it make sense? I will have more examples of that. But basically that corresponds when you program to Python lists and Python dicts, dictionaries in Python would be objects. Yeah. Okay. We'll have a few minutes. Oh, almost done. Okay. So this is an example of data set that you can download from the internet. This one, I think, has several millions of such objects, 1 object per line. I just nicely put it on multiple lines for you to read, but in fact, it's all on the same line. And you see target Italian sample choices. We have a list of choices. That's an example of use of an array, of an nested array. Guess German, date, country, and so on. And we can analyze this data set, and probably you will do that in the exercises. You can represent this collection of tuppers, that table, as a list of JSON objects. So this is an example of use of objects, right? You can represent nestedness in this way, as I showed you before, right? So a nested table would be an array of objects, right? Like you see here. And yeah, and that's pretty much it. So make sure that you have the visuals for that, that when you look at JSON, you have in mind this visual representation that you see above. Okay. I'm going to stop here for today. I'll do XML next week. Who followed today? Very good. So thank you very much for attending the lecture. Thank you everybody on Zoom. Thank you Zikai for moderating. Enjoy the exercises this week on HDFS. Don't forget to read the textbook. It's pretty much the same thing I'm telling you, but gives you another angle. If you have questions, ask them on the forum. We will answer them, and we also hear the TAs and me to answer all of your questions. Thank you very much. Have a good day ahead.